Great. Uh, Today we are on OWASP Bangalore. OWASP Bangalore YouTube channel after quite a long time. So I have Pankaj Maurya, who is one of the Null and OWASP Chandigarh chapter leader, and he's really brilliant in Docker containers. So today he is going to be briefing about the basics of Docker container and how we can have security with Docker containers. So I would give it over to you, Pankaj, so that you can go ahead and introduce yourself, tell more about you and about the session.
Okay. Yeah. So let me share my screen. So good evening, everybody. So my name is Pankaj Maurya, and so first of all, I would like to thank Vandana for this opportunity. And for me, if I tell about me, then I'm a student from Chandigarh, and I'm also a security researcher. I keep on learning random stuff, and yeah. So let's not waste a lot of time because I have a lot of things to explain. So I again welcome you all to Life in Docker Containers, the big picture. I'll explain the title, but before that, if you want to reach out to me, then you can reach out to me on Twitter at ROOT, R00T, root RWX, and also rootrwx.com. So let's start with the talk, and let's understand that life in Docker container, which means that how an application resides inside a container, and we will also talk about that whole overview of Docker and things related to it. So let's start. Okay. Yeah. So I hope you all can see my screen here. Vandana, is my screen visible?
Yes, we can see.
Why Docker, right? Okay. So first of all, let's talk about that why Docker. Why I am talking about Docker. So I have seen, so wherever you go, in whether you are sitting among techie people or you are in a company, wherever you go, you will find people talking about Docker. And these days, Docker is really a hot topic. I have seen like everybody is always talking about Docker container technology. So that's why I also wanted to learn Docker. So that's why I learned this topic. And yeah, one of the reason is this, that yeah, it is really a trending topic these days. So we should talk about it and we should really learn about it, that what is this container technology, what is this Docker. So what I will be covering today is, we will start with the introduction part, then we will talk about primer, some of the intro part, that how, when and why, and then we will talk about Docker, what exactly Docker is. Then we will also dig a little deeper in kernel Docker engine, and at the end we can have a Q&A. So my target audience will be the developers, security people, and the operational guys. So I hope that till now I am feeling excited and I want to teach you guys. So if you are really excited, then please have this expression that, yeah, I'm so interested. So let's move further. So let's start with the primer only, and let's understand the why behind the Docker containers and what, and then how you can use this. Okay, so it's a big picture, and I will be talking, and or you can say that giving you an overview of how this, like why this Docker technology came into existence, what was before Docker, and how all this thing works. So starting with the old days, so I hope that till now we all are aware that applications run businesses, right? Applications are the interface for for a business to run. You can take examples of any company, whether it is Google or Yahoo, whatever company, they have their applications and we recognize them using their applications only. So we can say that applications run business. And what used to happen in the old days, people used to, or you can say that companies used to deploy their single applications over single servers. And those servers, they seemed like big tin like servers, okay, and they used to cost a lot. And even after paying for that server, we still required the installation fee, the cooling devices, and somebody to monitor it, right? Once, like, they, even after paying for these all things, this we still lacked processing and scalability. And even if they were able to, you can say calculate or estimate the processing, they still lack the scalability. So what happened at that time, IT guys came up with the idea of overpowered servers. But again, what happened, these overpowered servers became underused. How? Let's see, suppose that I have a single server and I want to deploy a single application. Now my server is overpowered. So if my application, so say in this example, I'm taking the example of YouTube here. So if my application is using only 10% of my whole server, GPU or other things, then whole 90% is wasted. And in this way, we are not able to use all of our resources, and the resources are wasted, and hence it becomes underused. So what happened, like, this does not seem a perfect idea, right? Because why we should waste our 90% of resources? Then IT guys came up with the idea of virtual machines. Now, in case of virtual machines, we were able to use multiple apps over a single server. Now, again, I have given some examples like YouTube and Gmail. So just take it as an example. Now, suppose that again, I'm having my server here and I'm using multiple virtual machines. So in this way, I'm able to make maximum use of my resources, and my, you can say that my system resources are not wasted. And I've just shown here, you can see that 90% of my things are now used. So this seems to be a good idea. And as also we are able to achieve the scalability, we are able to run multiple apps over a single base machine. But somewhere it also seemed an imperfect solution, and we will talk about it why. So before that, let's discuss the architecture of this virtual machine. Yeah. So we have this base server here, and upon that we have our operating system, which can be a Linux or say Windows in this case. Now, suppose that I'm using hypervisor, or I have set up hypervisor, installed hypervisor in order to create virtual machines. So in this case, I have given 4 examples like Gmail and slides and other things. So suppose that I want to deploy 4 applications over this base machine. So what I'll do is, with the help of hypervisor, I'll carve 4 virtual machines, and they seem exactly like the base machine. They use the same GPU, same memory resources, and same storage resources. So you can see that once upon hypervisor, I have created 4 virtual templates, and upon that we install the guest OS, which can be Windows or Linux, and on that we deploy our 4 applications. So in this way, so there is one thing that why I said it is an imperfect solution, because even I have not yet deployed my application. Let's not talk about this application right now. So once you install the guest OS over your virtual machine, this guest OS starts consuming your resources, and this is not a good thing, right? Even my endpoint goal is to deploy an application, but before that only my OS is consuming resources, because again we know that window will consume some of the resources, some memory and some GPU, right? And upon that we have to deploy an application. So that's why it's an imperfect solution, and let's talk about it. So what are the disadvantages? As I said, that it will all it start consuming your resources, the OS. So now let's say that we have deployed our application, and now both the resources and the OS will start consuming my resources, right? So what happens? Okay, just suppose that you are okay with this. Okay, you are okay that okay, let it consume, and you are able to handle, and you are comfortable with all these things. But even after that, you have to pay for the licenses, because you cannot run a pirate window, and you can never run a pirate window in a production environment. So that's again another other thing you have to pay for. So you pay for the licenses. So the number of guest OS you have to pay for all those licenses. Now, even after paying for the license, you still need to patch, update, install firewalls, antivirus, or you need somebody to monitor it. Again, you have to pay for that person, or pay for these all costs. So it does not seem a perfect solution, right? Why should I pay for all the pirate windows? There should be something where I can have a single operating system and I can deploy all my applications. So that's where you can say the IT guys came up with the idea of containers. And again, I'll say that it is not that containers are just containers came after VMware. It is not like that. Containers are it is an old technology. It has been already available inside Linux from past many years. And why I'm saying that, why this should be used, because what happened that once they identified that these are the key problems we are having with the virtual machines, then people started moving towards, or you can say companies started moving towards the container technology, or you can say Docker. So now so if you see the architecture here on the right side, you will see that there's a server. Okay, just wait. Yeah, sorry to interrupt. So you see, there is a server, and upon that we have our base operating system installed. And containers, what they do, they abstract the feature of the Linux operating system, or you can say the operating system, and then carve small virtual OS. So here I'm using the word virtual OS, not virtual machines. In case of machines, we talk about the hardware resources also. Just like in the case of VM, we were having the hardware resources like the GPU, the RAM, and the storage. But in case of containers, it creates virtual OS instead of creating virtual machines. And these OS, you can say, are slices of the operating system, the base operating system. So here, if you see, containers are the slices of the operating system. And yeah, I have created four. I am taking examples of four applications, but it is not limited to four. And also, they do not eat our resources as compared to the VM virtual machine technology. And another good thing is that you do not have to wait for the booting of the guest OS, because in case of the virtual machines, your guest, first of all, you boot your main system, and then your system starts, you then start your virtual machine, and then upon that you start the guest OS, you boot your guest OS, and then you start using the applications, or you whatever you want to do inside the virtual machine. But in case of this container technology, you have just your base machine, and you just need to run a command, and your container will be up and running within seconds. So there are a lot of advantages which we can have, or the companies can have, using container technology. So yeah, so again, I have compared the architecture of both the virtual machines and the container technology. So you can see this again, we are not having the hardware resources here. And also, if you see that we can have various multiple containers because they do not consume much of our resources. So again, it is a plus point for it. So I hope that till now we all are clear and we are on the same point. Yeah. So let's move further and let's now talk about Docker. So let's say welcome Docker, because now we are really ready to see that, okay, this is the reason why we are using the container technology and why we are using Docker. So before starting about Docker, Docker has its own story of being that why it came into existence. Like it was a company. There was a company called Dot Cloud, and from them there only that Docker evolved, and they were all that company Dot Cloud was already using the container technology inside Linux. So they came up with their own idea of Docker and they made it public. So this is how Docker came into, you can say, existence. So now let's talk about life without Docker. So like there are big infrastructures. If we keep on using virtual machines, like that virtual machine which I explained, so just assume it has a big picture. So what will happen? You will have, you can say, if you're having more than 100 applications in your company, then you will have to deploy 100 virtual machines. So somewhere again you will have to pay a lot of money for it, and it will really cost it. So again, here we use containers. If you use containers, then it becomes a plus point, and we don't have to pay much. And then we have the Docker registry here. So it's kind of app store where all the services or applications are already built and transferred into image. So you have to just pull that image and you have to start the container, and you will have your application or service up and running. So it's kind of like app store only. You can just say a Play Store inside your Android system, Android phone, where you just install the app and you start using it. And just like on Docker, you go to hub.docker.com, and there you pull the image and you start using it by running it as a container. Security has been enhanced. The isolation feature provided by this container technology is really good. Then it is again cost effective. You don't have to pay much. I don't think it will be the cost will be as compared to the virtual machine. It will be less than that. And again, it saves times because within commands you are up and running with your application, and whereas in case of virtual machines you have to boot the OS, then you are up and running. So what Docker people say, build, ship, run any app anywhere, and that is true. So it is really easy to build your app and then ship and then run your app. So before starting the Docker, let's start with the introduction part only, with the definition only. So there are multiple definitions you will find over the internet, but I've found this one to be really easy and simple and can be understood by a layman person also. So in this case, Docker is a platform which packages a service into a unit, and that unit has everything to make that service run. I'm repeating again. Docker is a platform which packages a service into a unit, and that unit has everything to make the service run. So don't get confused about that unit word or the image. I'll explain all these terms later on. So if I say that I want to relate this with the real lifetime example and say that there's a shape and I want to live on that shape, so I need to have all the resources inside this house so that I can live here. So and that is the same case with the concept of Docker technology. So this unit, just call it a unit, and this unit has everything to make that service run or to make me live here as long as I want. So just like it, I'm defining that okay, Docker is a platform which packs a service into a unit, and that unit has everything to make that service run and that application run. So it is available in two editions, community and enterprise. In community, it is again open source, so there are a lot of contributors. The release cycle is really quick. In case of enterprise, again, it is not open source, so you people pay for it and you get extra support from the Docker people. Okay. So next thing is if you want to install Docker, you can either follow the blog of the official Docker documentation, or you can follow my blog, which I have written on nerdsplayground.in. You navigate to post and you will find proper steps reproduced to install Docker. And in case you want to install it on, AWS instance, even the instance, so you can also follow that thing. So next thing is, let's now talk about the architecture of Docker, that how exactly, that big picture of this all thing works, how you run a container, how containers are, stored inside the image and then run into a container, and how you pull an image from the Docker hub. So yeah, so there are three things here: client, Docker host, and registry. So let's talk about this client and Docker host. So whenever you install, Docker on your system, so this client and Docker host are installed on your system. So again, Docker host can be a remote also, or it can be local. So what happens whenever, so client is here like us, whenever we install Docker, when we try to execute commands from a terminal, so we are a client. Okay. So we run command from a terminal. Suppose that I want to run an Ubuntu image. So we run Docker run Ubuntu. So in this case, this image will go, this request will go to the Docker host. So here Docker host exposes a REST API using which Docker client basically connects to it over a local Unix socket. So when I say Docker run Ubuntu, this request goes to Docker daemon, and then Docker daemon checks whether this image is present inside the local image repository or not. If it is present here, it will, uh, you know, uh, convert it into a image. It will convert it, and then it will be up and running. So let me show you an animation that how it seems more easy and how it works. Okay. Yeah. So suppose that client runs a command Docker run Ubuntu, and then the request goes to Docker host, say Docker daemon. And okay, so one more thing, we will also talk about this Docker daemon also later on. So here the request goes to Docker daemon, and then the Docker daemon checks that whether Ubuntu is already present, Ubuntu image is already present inside the local image repository of Docker host or not. If it is present, it will execute that image, and then we will have our container up and running. So this is how the cycle works. Okay. And in this case, we do not require the registry part because our image is already present inside our local image repository. But in case, suppose that there is no image present inside the local image repository, then what will happen? Then in that case, that Docker daemon will talk to the registry part. Suppose that again, Docker and Ubuntu, and it goes to Docker daemon. It checks whether an image is present or not. In this case, we do not have that image, Ubuntu image. It will go to the registry, that is hub.docker.com, where all the registries, where all the image repositories are present. So it will pull that image, it will store it inside the local image repository, and then it will execute it, and we will have our container up and running. So this is how the architecture works. Okay. So one more thing before that, I'll talk about it. Yeah, so I think I missed this slide. So here we have three key terms which you should know before even talking about Docker. So we have Docker file here. So just assume it as a blueprint. Okay, just assume it as a blueprint which has all, in which we define all the things, where commands, what software to install, and what commands to run. So inside Docker file, we have all of these things. I'll show you Docker file at the end of the talk. And then once we build this Docker file, it's just a text file. Okay. So once we build this Docker file, we have our image. So this image contains, everything like the code, the libraries, the environment variables, and the configuration file. And once we execute this image, so we get our container up and running. So remember that the running instance of an image is called container. You can say like this. So container is the running instance of an image. So when I was talking about an unit in the definition here, so this unit is what we call as image. I hope that you are clear with the unit Docker file, image Docker file, and container keywords. Okay, so let's move further. So now have understood, we have already seen the big picture, and then we have understood what is Docker. Now let's talk. We know that okay, what is the architecture of Docker. Now let's talk about the kernel part. We always say that containers are abstracted from the base OS. Let's understand that abstraction part. So here, suppose that I have a base operating system, which is a Linux, and in Linux, so I'm normally talking about I'm now talking about containers, not exactly Docker. Okay, so what used to happen? This container technology, as I already mentioned, that it has been there from past many years, even before Docker. So companies like Google used to deploy their application inside containers only. They used to build hundreds of containers and deploy their application inside it. And at that time, even Docker was not there. So even if you still go into your terminal and you type in your Linux terminal and you type man namespaces, so you will find a detailed documentation about the manual about the namespace. So it shows that okay, that containers are already a part of Linux, even if you do not install the Docker. So now, if I say that what is container, so containers are built up namespaces and control groups. So it is like a mixture of control groups and the namespaces. Now, what is namespace? So namespace basically provides isolation to the containers, and you can say it provides a lot of other stuff which I will be talking about it. So it basically provides isolation. It provides all the process IDs, the name, user namespaces. There are a lot of features. I'll talk about it, and then we have the control groups. So control groups are used to control these containers. So once I have created a container, it should be controlled. Okay, I need to control the resources, like what kind of resources or what things to allocate and of how much memory. These all things are controlled by the control groups. So let's move further. So again, I have given the definitions. These are simple definitions like control groups limits how much you can use or grouping of objects and setting limits. In case of namespace, it limits what you can see, or it is about isolation. So I'm talking this in context of the container. So yeah, so namespaces again. So I will say that namespaces are just like the hypervisor. You can say in case of hypervisor, what happens? We have hypervisor installed over our base operating machine, and then hypervisor carves virtual machines which seem exactly like our base machine. Okay, and in similarly like that, we have our namespaces which carves the features of the base operating system and then create small virtual operating systems which seem like slices of the operating system, you can say. So if you see here, we have our process ID, process tree, okay, you can say, and then we have a root file system here, and then users, or you can say network stack. So once namespace create a container, it carves them into small virtual operating systems, like again having their own process ID, process tree, you can say, or root file system, network stacks, users. So if you see again, this single operating system, or you can say namespace container, is not aware about these other two containers. So this is how it seems like. And then we have, okay, next thing. So I hope that you are clear with the namespaces technology, that namespaces, that what namespace is exactly. So namespace is just not a name. It is built of a lot of different entities like PID namespace, mount namespace, UTS, IPC, network namespace, user namespace. Okay. Then we have, again, we have the definitions like PID, network mount, IPC, UTS. So where PID gives the container its own process ID, which starts with one. Then we have network, where network, each container is given its own isolated network stack. Mount is containers are given their own root file system. IPC lets all the single container to access, or you can say share the same memory. UTS gives the containers its own namespace, and then user namespace has been introduced later in uh, few days, you can say few years back only, and it allows you to map the a local user to an user inside the container as a privileged user, or you can say a root user. Okay, so next thing is we have again one more thing about namespaces, that we can share these namespaces either with the host or with the container. So when I say sharing, it means that if I have created a new container, then I can share that container with my host machine, or you can say host OS, or I can share that same container with the new container which is already running. So I can share the process ID with the host. You can say that I can share a process ID of a container with the host or with the container. I can also share a process ID IPC with the host and with the container. And I cannot share the mount namespace of a container with other two host or container. I can share the network and I can share the UTS with only the host. So this is how it seems like. We have container one here and container two here. And you can see that they all have their own namespaces here. So this is how it looks like. Okay. Now, next thing. Okay. So let's understand or let's see that how it exactly looks like with the demos part. Yeah. Just let me share my screen. Okay. So let's see that how it looks like inside a container, like how namespaces look like inside a container and on the base system. So so as I've already said that namespaces are part of containers, not Docker exactly. So even if you have not installed the Docker, then you will be able to you see the namespaces and the control groups inside your Linux system. So let me show you. Let me share my screen here. Yeah, share. So here I'm having two terminals here. Okay, I hope that it is visible right now. Right. Yeah, hope that it is visible. So here what I'm doing is, let's say that ls null. So if you see this is basically our namespaces here. So you see, okay, CG group is new one. So it is a little bit confusing. So I'm not mentioning it right now. So we have other namespaces like IPC, mount, network namespace, PID for children, user, and UTS. Okay, so I hope it is visible. So now let's see this same namespace in a container. So I'm running a container here. Yeah, Docker. Say that I'm running the Ubuntu image. So don't worry about the commands which I'm using here. I'll explain all these commands when I will be covering the demo part. Okay. So now we are inside the Ubuntu shell. Let's type the same commands in order to see the names inside our container and what is the difference between them than that of the host OS. So if you see here, we have this IPC. It is totally different from this. IPC of the host is different from the IPC, container of the Ubuntu, right? The mount namespace is different from the mount namespace inside the container. Then network is also different. PID is also different because as I've already said that it is about isolation. So each container has its own PID. If you type here PS, you will see that it starts with PID one. So that it shows that okay, namespaces are really about isolation. And then the user namespace is different because it's same. It will be same because just because of the user namespaces. So you can say that when we do not enable user namespace, so what happens is that the root user, you can say that the same user is mapped with the user inside the container. So this is how. So by default, Docker maps the root with the root of the container. or you can say that the root of the container is mapped with the user of the base system, that is root. So this is how it looks like. This is how the namespace looks like. Then we have UTS also. It has different namespace. So we'll talk about user namespaces if I get time, and because it is really a interesting, you can say, entity or topic to talk about, and because it allows you to. So once you enable the user namespace, it allows you to map the users. Okay. So let's exit from this container right now. And yeah. So this is how it looks like. So we are done with the namespaces. So let's again get back to the slides. Okay. So suppose that now we are having four containers running here. That is, say that 1, 2, 3, 4, and all they have, all of the containers have their own process ID, their own network stat, or you can say their own namespaces. Now the suppose that in container 1 I'm running a static application, a single application, but in container 4 I'm running, you can say, Ubuntu image. Okay, and you can say that inside that I'm running a tool called stress. I hope that you are aware of the stress tool, which is used to check the system capability by making it to consume all of the resources. So right now, this is container 4 is creating all consuming all my resources, but container 1 is not. It is a light application. So what will happen? I need to, have something to control these containers, right? So what we have for this, we have control groups. So control groups helps us to control that how much amount of resources to allocate to a particular container. So that how much amount of RAM, CPU, or disk to allocate to a particular container. And I will be mentioning the Gitbook, which I have written for security of the Docker. So inside it, I have mentioned about the practices, security practices, you can say, by using the control groups. So inside that, you will find that I have mentioned how I've used the image of stress, that tool. I've created a container for the stress. I have run that image. So once you run that container, it will start consuming your base resources. And then you can again you can stop that container, and then you can again use that same container by using the control groups features. And then you will see that you will be able to control the resources. So I have mentioned the practically there, very, beautiful, you can say. So you can go and you can reproduce the steps and you will find how exactly control groups work. So now we are aware about namespaces and then control groups. So now we have done with the abstraction part, that how abstraction is done. So now let's talk about, or you can say that little dig deeper about the Docker engine. So in the starting only, when I was like showing you the architecture of Docker, that how exactly Docker client, Docker host, and then registry part, if you remember. So there we talked about Docker daemon basically. So that is the same part, Docker engine here. So now we are going to talk about the daemon only. So if I define this, then it's the Docker engine which manages everything, like the generating an API request, handling the kernel level stuff, or creating containers. So when we say handling the kernel level stuff, it is not about abstracting the feature. It is about how to interact with the kernel. Okay. So here, if you see, we have the client which uses this REST API to connect to the Docker engine, or you can say the Docker engine. Yeah, Docker daemon. And then Docker daemon interacts with the kernel level stuff, namespaces and control groups, and it abstracts the features and then runs the container. Okay, so if say that the client says the Docker and Ubuntu, so it will abstract features which are required for Ubuntu. You can say, and then our container is up and running on this side, right side. So this is again a big picture, you can say. So now let's dig a little deeper and understand this, how this exactly Docker engine works. So in case I'm speaking like faster, because I have to cover a lot of things, I think. So what you can do is, well, you are watching, so you can slow it using the, if you're on YouTube, you can slow the speed, right? And you will get like better understanding of the things. Okay, so yeah, so let's understand the Docker engine background process. So we have this client here. Client uses the REST API to talk to the Docker, where daemon. We also call it daemon as Docker D. And where again we can say that the power function of Docker daemon is to handle the API request. Or also, if you remember, then that daemon checks whether the image is present inside the local image repository or not, all this thing. And then we have, then daemon further talks to the container D. So if you're creating an image, so this is if you're creating a, you can say, container, running a container, so this is how the whole process goes on. Client, then daemon, and then container D, and daemon talks to the container D using a local socket, gRPC socket, you can say API. So it goes there, and then here container D, its function is about the execution or the life cycle of the container. Basically, it handles the execution lifecycle, like starting the container, stopping the container, pausing the container. And then, and the last, which is responsible for creating the container, is the OCI, which stands for Open Container Initiative. So it's a kind of standard in which it has two things, like the image specification and the runtime specification, which defines, so which has, you can say that, which has the controls or checks of how to create containers or how to interact with the kernel level stuff. So why we are using OCI? So that we all are on the same page, right? Because we follow standards, so that we all the people inside the world use the same thing, same language. So that is why we use OCI here. So let's again see the animated slide and understand how whole this process goes on. So here, let's start with the command that Docker client runs a command, Docker container run. Then the client uses the REST API to connect to the daemon, or in order to create a container. So this request, you can see this post request, even to post, even to container create HTTP 1.1. So this request goes to the daemon, but again, daemon does not has the logic of creating the containers, because it only handles the API request, or you can say that checking the image repositories whether present or not. So this request further goes to the container D, as I've already mentioned. So it again talks to the using gRPC, and the request goes to the container D. But even the container D also does not have that logic of creating the containers, because all those logic of writing the you can say the writing, or you can say interacting with the kernel level stuff, abstracting the features of the kernel, are written in the runtime OCI. So what container D do? It creates a sim process and then a runc. So runc is exactly an entity which interacts with the OS, base OS, abstracts the feature, or you can say interact with the kernel and abstract the features, and runs a container. So here shim is a small process. So what happens that whenever we run a container, or whenever we, you can say, start a container, create a container, this runc is a long process. So if this runc keeps on running, then the processes will be very slow. Whenever we execute a command or we run a container, it will take a lot of time to spin up. So what happens that whenever we run a container, just after runc creates a container, it immediately exits, and it allows it gives all the controls, you can say, to the shim, so that shim creates an interface between the container D, or you can say Docker daemon, and the container. So this same process goes on with all the containers. So whenever every time you run a container, you will find this whole process going on. Okay. So again, there are multiple other things with the daemon. So let's save our time. These are not that much important, I think. So next thing is Docker demo. So now we will talk about some of the basic commands which we should use, or which if you see, you will be able to start with Docker if you are new to Docker. Okay, so let's understand that. So what I have done is that I have created, divided these commands into two parts. You can see the devs and the ops. So that's why I'm saying it, Docker and DevOps. So if you see, so what happens in the ops part? Normally we do is we pull an image, we start a container, we log into the container. You can say we start with the interactive shell of the container. We run commands. Once we are done with the work, we destroy the containers by stopping it, by removing it, the image, particular image. And if you are, you can say, you are at a part of developer, then stage of developer, then you develop an app, you put it into version control, whether it can be GitLab or GitHub or any other version control system. And then from there, you pull it, you containerize it using a Docker file. So here I have mentioned looking into a Docker file, you type the commands, whichever the requirements are. And I hope that you are familiar with the Docker file, which I mentioned as a blueprint. So inside it, we have all the commands which required, or software, or which are required for our service to run. And then once we have created Docker file, we build that image, or we add it to the registry, that is hub.docker.com. Also, let's not miss the security of Docker. So there are many testing frameworks. So if you are like in the security part, so you can test your Docker platform or your Docker workload. You can container workload using the where there are various testing frameworks like container structure test, dgos, docker spec, docker unit, inspect, pomba. So inspect and one more, that is docker bench for security, which is created by the docker only. So we have CIS Docker benchmark, Center of Internet Security. So what it does, it has defined all the controls, or you can say checks, which if you go through, then you can be sure that okay, your platform is secure or your workload is secure. So inspect has a lot of profiles, using which you using that profile you do the testing of the platform, of Docker platform. And Docker bench for security, I have not mentioned here, but it is again has it follows the CIS Docker benchmark only to do the testing of the you can say the framework or platform or the container workload. So I'm again mentioning that I will be mentioning two Gitbooks at the end of the talk. So it will be docsec and doccube.rootrws.com. So if you go to the docsec, you will find about inspect and the Docker bench for security in detail, and you will be able to use that how you can make use of docsec to do the testing of the Docker platform or the container workload. So let's move further and let's start with the commands. Yeah, so it's demo time. And okay, just give me a second. So I'll again share my screen so that we can start with the commands. Yeah. Yeah. Till that you can have your break, or you can whatever you want to take off or something. I'll take another few minutes. Start with the command. So Docker version, yeah, ops work. So as I mentioned that I have divided the commands into two steps. So doc ops and the devs. So let's start with the ops part. Okay. So I'm sharing my terminal here. I hope that my terminal is visible. And yeah. So suppose that you have installed your Docker and you are like you have a fresh installation. In my case, I have already installed and I have already a lot of images which are already stored inside the local image repository. But still, it will make sense. Okay, I'll explain the things. So let's start with the Docker help so that you are aware that if you are not aware of any commands, you can directly go to the help section and you can find all the commands here, like creating the commands for attaching, creating, building the containers, everything. So they have mentioned everything here. So you can, if you want to go with more of the commands, you want to try more things, then you can go with this help command. So now let's start with another command which you should use in order to see that whether your Docker is properly installed or not. So once you say Docker version or you type Docker version, you will find that there are two things, client and server. Okay, let me check whether my screen is visible or not properly. Okay, I hope that my screen is properly visible and you can see proper commands. Okay, so once you type Docker version, you will find that there are two things, client and the server. So here, so in this case, this root RWX user, it's a local user. Okay, I have added this user into the sudoers group. That is why I'm able to run the command without sudo. Okay, but if you have installed a fresh, you have done a fresh installation of the Docker, so you need to, and you are a local user, so you need to use sudo command in order to execute the commands or to play with Docker. Okay, so please keep this in mind so that you are not like messed up with, okay, why my command is not working. So here, when you type Docker version, you have client and server. So it shows that your client. So now when I'm typing Docker version, I'm a client, right? I'm running the commands as client. So you remember the Docker, you remember the architecture, client and the host. So you can say this is the host, the server, the engine, and this is the client. So here I can see that both my client and server are available, and the client is able to talk to the server. And as I've already said that you need sudo commands to execute the commands. Let's say that I'm switching to a new user, test one, and it is not added to the sudoers group. So in this case, when you run docker version, so you will only see the client because you are client, right? But you cannot see the server part because it you as I've said that client uses a local socket, local unique socket to talk to the docker host. So this is the local unique socket which says that you need permission in order to execute the commands. So that is why you should have either you should be a sudoers user or you can use sudo commands. So let's again go back to the root rwx, and yeah. So let's move further. So now that I hope that you are good with this command docker version and my installation is proper. My both client and server are talking to each other. So next thing is you can type docker info. You can use the command docker info. These are some of the important commands which should be aware of so that you are aware that okay, what things are going on. Like if I type docker info, so it shows that number of containers available, number of images available, number of containers basically running, a number of posts stopped, images available, server version, or you can also see the kernel level version, architecture, CPUs, total memory, everything, the name of the system, the base system basically. So again, docker info is really a good command and it gives you a lot of information, meta information you can say. So now let's see that how many what is the local image repository which I was talking about. So when you type local docker images, so you find that it gives you the local image repository and the number of images available inside it. So in my case, I have a lot of images available. I have pulled a lot of images from the hub.docker.com, or you can say root rwa, or you can say that I have created my own you can say images by building it by using the docker file. So here you can see this life in container. So it's an application. It's basically the Gitbook, which I will be showing you at the end of the talk. So this is the Gitbook which I have created into container so that if anybody wants to run it as container, they can run it. Then we have, again, there are other machines like OS like Paco, the lab, Ubuntu OS, Alpine OS, Python. Okay, there are a lot of things. So this is how you check for the images. So in your case, if you do a fresh installation of the Docker, you will not find these Docker images. Okay. So now suppose that I have this Docker Ubuntu image. So what will happen that if what I have to do is I have to run. So don't worry about. So okay, I'll tell you about RM. Now it's the time when you should know about some of the commands. IT. And then you can also name it. So here RM shows that once I exit the container to remove this image or to remove this container, or when I say that my container is running and I shut down the computer, so it will remove the container from its running stage. Okay, and it will stop the container. IT means where I tells that to be in interactive mode, and T tells to attach our current terminal to the shell of the container. You can see this. The name is basically it provides name to a container. Suppose that in my case, I'll say that let's say Ubuntu only. It will be easy. So now what you can do is now you pass the name of the container. So what we have done, Docker run. Either you can directly pass an image name. Suppose that okay, let's try this.